Okay, good morning everyone. Am I audible? Please response anyone, am I audible or not? Hello? Hello class. Am I audible? Hello?
Yes, sir.
Okay. So just wait, I am starting. Okay. So very good morning, all of you. So we have started today our new topics, that is the transducer chapter, string. Okay. Just wait, I am sharing my screen. Okay. So today we will discuss the string word. So anyone, any idea what is string word? Also, if you when you have to read any physics, that is physical science, and sometimes you have to listen this string word. Okay. So okay, so string word basically it is uses one of the transducer device in our electrical and electronics appliances also. Okay. So first of all, it is basically it is invented. It is invented by Edward E. Simmons and Arthur C. Arthur C. in the year of 1938. Okay, so please remember these things also. So first string gauge, it is invented by the scientist Edward Simmons and also Arthur C. Both scientists had first invented this string gauge in the year of 1938. So first of all, you have to know what is the strain gauge. Basically, this strain gauge, it is basically a device. It is used for measuring mechanical surface strain. Okay, so I am written the definitions. A strain gauge is a sensor whose resistance varies with applied force, and it converts force, pressure, tension, weight, etc. Okay. So first of all, you have to know what is strain gauge. This strain gauge, it is basically one of the sensor whose resistance is varies with the applied different of application. So here the resistance it is also varies with the applied force. What type of force you have to apply it in the input section of the strain gauge system. And this strain gauge, this force it is converts, either it is force, another is pressure, either tensions, another also weight, etc. So these are the basic parameter you have to convert the input to the output sections. Okay. So here one thing is also important. When external forces are applied to a stationary object, stress and strain, stress and strain are the result. So here stress is defined as the object internal object's internal resisting force and strain is defined as the displacement and deformation that occurs. So this is the basically idea what is strain gauge system. So first of all, I am repeats once again. So first of all, this strain gauge, it is basically one of the sensor whose resistance it is varies with the applied force. Okay, that type what type of force we have to apply into section of the strain gauge, and it is changes. This resistance is it changes force, pressure, tension, weight, etc. So when the external force are applied to a stationary object, stress and strains are the result. So these two terms it is very much important. It is related to the strain gauge system. So stress and strain. So what is stress and strain? So basically stress is basically defined any object, its internal resisting force. It is called the stress, and strain is the defined as the displacement or deformation that occur. That means after you have to apply the force in any object, so this object it has internal resisting power or forces. This internal resisting forces of any object, it is called the stress, and after you have two forces given, this force or it is applied, either it is displacement or any deformations. So this is called the strain. Okay, is it clear?
Yes, sir.
Is it okay? So this is basically called the strain gauge system. So in our measurement, there are lots of applications are available in the strain gauge area. Okay. So first of all, application where the gauge measures strain as the primary object, primary objective of measurement, as in the case of stress analysis of machines and structures. And another one where measurement of strain is utilized in transducer as a measure of another parameter such as load, pressure, acceleration, okay, or any other etc. Any other applied areas. So this is the basically application area. So first of all, this transducer strain gauge, it is uses the gauge when the gauge measures strain as the primary objective, and the measurement as in the case of the stress analysis of the machines or any structures. That means when you have to use load cell. Okay, so load, when you have to apply the first load, so this is the basically primary object. Then this load, it is also measured the particular weighted any object or any particles. Okay, sometimes it is also that is it uses in that heavy weight truck in the load cell, using the load cell. Okay, that is a weight bridge. So this is the basically first of applications of the strain gauge. And another one where measurement of strain, it is utilized in transducer as a measurement or as a measure of the parameter, different parameter, that is load. Sometimes it is also changes pressure, accelerations, okay, weight, tension, etc., torque, etc. So these are the basic uh, application area of the strain gauge system. Okay, is it okay, all of you?
Yes, sir.
So in the corresponding of the applications, we have to basically classify it in our strain gauge different categories. So classifications. Classification. First of all, we have to use this as a mechanical gauge. Okay, so in the mechanical gauge, this is basically uses for static strain measurement. I'm written here, measure for static strain measurement. Okay, so in the mechanical gauge system, this strain gauge we have to use this for the static strain measurement. Okay, another number two is optical strain gauge. So optical strain gauge, it is basically similar to the mechanical gauge system, mechanical strain gauge system, where the magnification is achieved the multiple reflectors using mirrors or prism. Okay, mirror or prisms, and measurement accuracy is high, independent to the temperature variations also. So basically, optical strain gauge, it is same as to the mechanical strain gauge, and it is basically uses another magnification. I am written here, magnification with multiple reflectors using mirror or prisms, and measurement accuracy is high. Accuracy is high and independent of temperature variation. Temperature variation. So this is the basically called the optical strain gauge. It is uses as same as the mechanical gauge system, and it magnifications with multiple reflectors using the different types of mirror or prisms, and measurement accuracy is high, and it is also independent of the temperature variation. So temperature in, when you have to working in any humidity area or any hottest area, that is temperature, it is also changes. So in that case, you have to use this optical strain gauge system. Another one, number third, electrical strain gauge system. Okay, so this electrical strain gauge, it is basically working based upon the measurement of the change in resistance, you know that, capacitance, inductance, and it is proportional to the stress and strain. Okay, so I am written just one of the gist. So measurement of the change in resistance, capacitance, inductance, etc. And that are proportional to the strain transferred from the specimen to the basic gauge element. So these three types of strain gauge we have to use it in our industry purpose. Okay, so mechanical gauge, optical strain gauge, or electrical strain gauge. So these three types of strain gauge we have to use this in our practicals. Okay, so in our industry field, basically in our department oriented, we have to basically use this electrical strain gauge. So this electrical strain gauge, it is basically related in our two terms I am previously trained, that is stress and strain. So first of all, you have to know what is stress and strain. So anyone please tell me what is stress and strain, what is the relation between the stress and strain? Stress and strain. So you know that young modulus, you know what is young modulus. So please remember this thing, this is very, very important. So strain is directly proportional to stress within elastic limit, within elastic limit of the material and the ratio of stress to strain is called Young modulus. Young's modulus of elasticity of material. Okay, so this is basically called the Young modulus. So please remember these things also. What is strain, and what is Young modulus? I am repeats once again. So stress is basically directly proportional to the stress within elastic limit of the material. What type of material you have to use, and you know that every material it has a elastic limit. Okay, because you know when you have to press the one rubber, so this rubber, it is also particular limit of the elastic limit. After some time, when you have to stress the rubber, after a one time, this rubber it is also broken. Okay, so just particular broken stage, that is the before of the broken stage, it is the basically elastic limit of that type of rubber material. Okay, so this is a rubber. So what type of material you have to rubber? That is steel, that is nickel, or any type, aluminum, any types of material you have to use this, that has a elastic limit. So elastic limit of the element material and the ratio of the stress to strain, it is basically called the Young modulus of elasticity of the material. Okay. So this Young modulus we have to express, that is capital E. You know that. So capital E, that means Young modulus this is equal to stress by strain, and here we have to express the stress by strain, that is small p by epsilon, and it is the unit kg per meter square, where P is the axial stress in kg per meter square, and epsilon is the axial strain. Okay, so this is the basically relations of the stress and strain, and it is basically called the Young modulus. Is it clear, all of you?
Yes, sir.
Okay. Next, operations. That is the principal operating principles of the strain gauge. Operating principle of strain gauge. So this strain gauge, you know that it is basically based on the fact when the stress is applied to the metal conductor and its resistance, it is also changes in the any direction, that is a length, x direction, something like that. Okay, so I am drawing a picture, then it is very clear. This is the inner material structure, something like that, and this is the outer side, something like that. So this to this length, this is basically small l, and this to this is basically a delta l. Okay, force we have to apply F, that is the both sides, outer side of force, and this type of material unstressed, and this material is stressed material. That is, this material it is also stretchable, and this is the basically cross sectional area of these two types of material. This is circular part. So in here diagram it is not circular, but you have to consider here circular. And this is the basically area delta A, and this area it is also A, and this delta A is the inner area, inner portion. This area is it is the delta of A. Okay, so now when this strain gauge, it is basically applied when the stress is applied of the metal conductor or semiconductor material, the resistance it is also changes in the length. Okay, so this effect, this resistance of the conductor under stress, it is changes due to the change of the resistivity of the conductor. So this property it is called the piezoresistive effect. That is piezoresistive effect. Okay, I am repeat once again. So when the strain gauge, it is based on the fact when the stress is applied to the metal conductor, its resistance is changes, and the length of the it is also x sectional area, it is also changes also stress, that is a stress material. So this resistance of conductor under stress it is changes due to the change of resistivity, it is called the piezoresistive effect. Okay, so the resistance of unstrained this unstrained the conductor, so we have to express here R is equal to rho into L by E. Okay, so Here the length and also area, it is also changes when you have to force is applied. Okay, so the let under strain condition resistance of conductor be changed by, that is delta R, because of change in length. Okay, is it clear all of you? That is length is changes, that means delta L changes. And another one, cross sectional area by, this is delta A, this A is the area, L is the length, okay, R is the resistance, you know that, and rho is the constant term of the strain gas strain constant. Okay, so delta A and resistivity. Everyone write your own name and roll number in the chat box also. And Rahul is present, regular student Rahul, please respond me. Rahul is present. Muskan is present. Please respond. Rahul or Muskan not present. Okay, Abhishek Kumar. Abhishek, are you hear me? Abhishek Kumar. Aman Kumar. Please respond me, Aman. Yes, Punit. Punit, you take a screenshot of the participant list. Okay, and after ending the class, you have to send me my WhatsApp. Punit, are you hear me?
Yes, sir.
Please response.
Yes, sir.
Okay. Okay, so the resistivity by the delta rho, this is the delta rho, we have to measure. So now you have two changes. So the equations, first of all, we have to written here. Just wait. So you know that is R is equal to rho into L by A. So now differentiating expression, this is the equation 1. Differentiating equation 1 with respect to stress. So that means dr, that is ddpr, this is equal to pdp into rho into L by A. So we have I have write it, that is rho by A into DLDA minus, then you know that rho L by A square into DADP plus L by A or D rho by dP. This is rho, not touches. This is rho. So this is the equation 2. Now dividing both sides of equation 2 by R, we get, so we have to apply this, we have to divide both sides by R, and we have to also apply R is equal to rho by L in the different positions. So I am simplify the equations, that is 1 by R into dR dP. This is equal to 1 by L into dL dP DLDP, sorry, this is a DLDP minus 1 by A into dA dP plus 1 by rho into d rho by dP. So I am repeats once again. So in that equations, we have to both sides divided by the R, and we have to apply it here also. That is R is equal to rho into L by A. Okay. So when you have to divide it by R, that means below part is R. So this is also A by rho L. So A and A is cutting, rho and rho is cutting. So L, that is a 1 by L equal to DL dP. So you have to apply every area, every point. So this is R is equal to rho into L by A. So for above expressions, we have to write for small variations. For small variation, above expression can also be written as, that is del R by R. This is equal to del L by L minus delta A by A plus delta rho by rho. So this is the equation number 4. This is very much important. So when you have to consider for the small variations in the resistances changes. Okay, so that means these are the basically equations: del R by R equal to del L by L minus del A by A plus del rho by rho. Okay, and you know that area is considered A is equal to pi by 4 d square. Okay, so up to this part it is clear, all of you.
Yes.
Next part we have to discuss in our next classes. Okay, so what is the basic gauge factor, what is the basic application, what is the different types of strain gauge materials. Okay, so today is less than 1 minute. So this operation of principles, it is very much important for your exam purpose. Okay, ये क्वेश्चन आप लोगों को एग्जाम में आ सकता है, so please इसको एक बार क्लास में देख लेना. So